Hello everyone. In this exercise of SolidWorks, we will create, we will, uh, we will calculate the shear force in two plates which are connected by bolts and nuts in SolidWorks simulation. Okay, let's start. File, new, assembly. Oh, I have made two plates. Already made two plates. Browse. This is the assembly window, browse, and this is the plate one. I am selecting this one. This is the plate one. Okay, and I am rotating it Y. This one. Again rotating Y. This one. This one. This is the position, and I am not clicking in the graphic area, and this one. This in the view head-up tool, there is the hide and show item. Click here, and this is the view origin. Okay, and again go up in the view head-up tool. Click and the scroll and move it, and this join it here. This is this one. Okay, this is located at the origin of the assembly part. Again go in the view head-up tool and click there, hide the view origin. Okay, this one. Background plain white, this one. Now this part is fixed. You see left hand side tree manager, this part showing the F sign. It means this part is fixed. Now I am taking another part. Assembly, insert component, this one. Again this window comes. You can select here two plate, this one, and open it. This one. This I am clicking in the graphic area. Okay, now first mat, select this one, and select this one, this and this. It's coincidence relation. Click it. Now again cancel it. Mat, this hole, second one, hole, select hole, and this hole, concentric relation. Okay, this one. Now you will see at the bottom the mates are underdefined. At least 3 mates are essential in order to define the parts. Okay, now I am making third mate. Select this one and this hole you have to select this one, concentric relation. This is fully defined. In order to make the fully defined mates, the 3 constraints are essential. Okay, in 6 degrees of the freedom. Okay, this I am cancelling. This is the assembly. Okay, unit system, the milligram. These two 8 mm holes, and if I am selecting this, I am selecting this one and this open part. This one. Now this is 2 plates I have made here. Okay, now in assembly, first this is the simulation tab. If this tab is not coming in your tab section, you can go in option, add-ins, and from here SolidWorks simulation, you can check it and okay it will come in the graphic, it will come in the tab section. Okay, but I have this one, simulation, new study, static. This is the static study. I am taking shear force, static shear force calculation force, this one. Okay, and hit the right button. This now this new window comes here, future tree manager, and now first I have make a name I have given to the study, static shear force. We will calculate the shear force parts. Apply the material. First apply the material. Apply material. You can take any material, you can take as per your requirement. AISA 30, apply, close. This one, material has been applied here. If you this one, if scroll this, this mark will show that metal has been applied, both the plates. Okay, this one. Now second is the fixture we have to apply it. Later on we will apply the connection, because there are more than one parts here assembly. Whenever there are more than one parts in the simulation, we will have to connect the part by fastening devices. Okay, first I am applying the fixture cross, I apply the fixed. Why I am fixing? Because in order to make the steady static, we have to fix one part. This one I am selecting, this one, this bottom part I am fixing here. Okay, hit the right button. Now apply the load. Apply load, right click, force. Force is the force SI system, and suppose I am applying the 20,000 Newton. Okay, select the face. This I am applying this, but direction is towards this side. No, I want reverse it. This one. In this way I am applying the force here. Okay, this one. Now apply the connections. Connection are applied because of the connections. The parts are connected with the help of fastening devices, because if there are more than one parts. Okay, right click and bolt. I am connected with the help of bolt. This one. This window comes here. Select main normal bolt, standard. Okay, select these two boxes. Select this edge. This one. This is the bolt. And second box, you select the bottom of the same hole. This is for the nut. This is the for nut. Now automatically head dia and the bolt hole. This is the hole of 8 mm size in the millimeter. Okay, distributed connection type I am taking distributed. Okay, now material alloy steel, or you select the material as per your requirement for the bolt. Okay, or custom, you can take the material from selected and take the material custom. Now strength data. What is the strength of this one? Known tensile stress area, I am taking calculated tensile stress area. Okay, threads per millimeter, I am taking the pitch is 1.25. Taking the pitch of the bolt 1.25. Okay, bolt strength is this one, Newton meter square. I am taking in the Newton per millimeter square. Okay, factor of safety is 2. Factors of safety must be more than 1. Okay, in order to make the product safe. Normal preload I am not giving this one. Advanced obstruction I am remaining as it is default. Okay, this diagram. Now you click this pin. Okay, now you have to select and hit the right button. Now for the same you have to select for the these parameter have same parameter have to select for the another hole. This window select this one and this one. This one, this for the bolt, this one, and this for the nut, bottom one, this one. Okay, this automatic comes head dia. This is the whole dia. Distribution connection time, you distributing for the proper calculation distributed. You take the library alloy steel. Alloy steel selected default. If you change the material, you can change it. Custom, you can take it. Now bottom you come. Strength data. Known tensile stress. If you known the tensile stress, otherwise calculated tensile stress. Because in the shear forces, shearing will take place at the threaded section. In the threaded shank section. So I am taking the pitch of the bolt. That is the 1.25 threads per millimeter. Bolt strength I am taking in the Newton per millimeter 620.422. Okay, safety factor 2, and this one hit the right. Same parameter for this one, and cancel it. This now you have select bolt and the nut have been applied. Because if the parts are more in simulation, if the parts are more than one, you will have to connect by the some fastening devices. Okay, one part I have fixed and other two also have been connected. Okay, now connection. One thing more, that is the local interaction, where the bolts are there, local interaction. This one, local interaction, automatically find local interaction. Local interaction near the bolts area. This one automatically I am selecting, system will automatically detect the interaction, but select the components which, and this one, this and this one, these two parts I have selected. Okay, find local interaction. System calculates the interaction. Okay, this one, and hit the right button. Do you want to create selected local interaction? Yes, I am selected. System default selects the local interaction. Now mesh, create mesh. This one. This mesh parameter, you can take standard mesh. I am taking standard, but you can change the finite element sizes and the tolerance of the elements. Okay, you will keep the sizes of the finite element less, then the calculation will take more time, and but the results will be very precise. Okay, you can here you can find increase. I am taking just mid course, you can take it fine. If the mesh density will be finer, the calculation time will be more, but the results will be precise. Okay, but I am taking in the mid of the course and fine, and this now run this study. Warning, preload in the at least 1 volt connector is 0. Do you want to continue? Yes. This is calculating. This one. This is the, now you will see stress. The stress value is coming this one. The stress, that is the yield strength is 2.068 into E. E means 10 raised to the power 8. E means 10 raised to the power 8. This strength means if this much load is applied, the component can bear this load without deformation. Okay, but okay, this is the legends for the stresses, but you will see the stress, if you go beyond 2.068, that is the yield strength value, the stresses are developed here. In this area you say gray area, this one, this gray area are the for the stresses. Here the stress are developing in this section. Okay, the stress are developing here. You can suppose right click, edit depth chart option, and show maximum, minimum, you can find out. Okay, and this one, this is Newton unit, you will take it Newton per millimeter square. Scale, true scale. Actually this is showing automatic scale at a point. I am taking true scale and hit the right button. These are the stresses. So the product, actually the stresses are developing in this way, in this gray area. Here the stresses are more. Maximum is this 7.757 into 10 raised to the power 2. That is more than the yield strength. It means product is not our safe. Okay, product is not safe. In order to make the product safe, design parameters, material thickness, type of material will be, you will have to change. I have made videos for in order to make the product safe. Calculation of the factor safety, you can see on my channels. And now our main purpose in this is the calculation of the shear force calculation. This volt axle load is applied, so what is the shear force in the bolt? Okay, so how I have applied the 2000. How we can calculate? You can go also in this result advisor, you can go, or here click here results, and you define pin bolt check plot, or you can also select the you can one more thing here, list connector force. You can, both the things can be done. Suppose I select define pin bolt check, this one, and this box comes details. Please tell the details. This is the details of this one. Okay, this is the details of the shear force. All boards and the unit system is this one. This is the force. You will see our force, resultant force is 10,000 shear force on the first bolt, and second for shear force is this one 10,000. Our x component is this is the force. X component is the 10,000 and 10,000 here. These two components, these 10, because our total load is 20,000 Newton. Our total load is, you will see 20,000. So this is distributed uniformly in these two bolts. 10,000 by this first bolt, 10,000 is this one. Okay, this is the applied force, and shear force is this one, X component, and this is the Z component, Y component. Shear force in this way, first bolt this one, X1, and second shear force this one. In this way you can apply, calculate the shear force and save it also. You can save also this one. In this way you can calculate this one. You can also calculate from here also. Result advisor, list result force, you can also collect from here, and you can update it. This from here, this one connector force, yeah, also you can collect. Same window comes here. This one. You want to note the components, list XYZ component, you can check here. Same thing. You can, and here you can shear force. This you can calculate from here. This one component X, you will see our resultant force is 10,000. Okay, this one in our applied force is this one in X direction. This direction, and the shear force also developed here, X, Y, Z. This X component and Z component. Okay, in this way you can calculate the shear force. Suppose displacement, double click displacement is coming here. This 2.699 into 10 raised to minus 1. This E means 10 raised to minus 1. And 2.699 divided by 10. And this displacement is taking place 0.2 mm displacement. Right click, you can chart option, you can show maximum and minimum displacement. Definition, you can take millimeter value, automatic scale. I am taking true scale. True scale means actual scale, this one. And right click, animate. This you can animate. This is the speed, you can less it and pause it. You can increase the frame rate. You can change the speed also, and you can start it here. You can save this file also. In this way we can calculate this one. In this, you want to, suppose you want to change in millimeter, to you go in the chart option. Here is this window, you will see scientific, you can change the floating. So this value comes in the millimeter. You will see in the chart legend, you will see this is in millimeter, and 0.270 is the displacement taking place in this one. In this way you can calculate you can also calculate the factor of safety, but I have made 2-3 videos on the YouTube channel for calculating the factor of safety. Okay, so in this way you can calculate the shear force and stasis. This one you can also check the factor of safety. I hope you would have enjoyed in this exercise. You please like, share and subscribe this channel. Thank you.